Hello everyone. Today in this video lecture we will be covering hybridization, which is a subtopic of chemical bonding. Now hybridization is basically a term given to the phenomena of mixing of orbitals. This mixing of orbitals is exactly why covalent bonds between different non-metallic atoms occur and why they can be formed. Now, hybridization in our syllabus is only related to the hybridization of carbon atoms. Now, we will be studying three types of hybridizations: sp3 hybridization, sp2 hybridization, and sp hybridization. Now, what we need to realize is that sp3 hybridization is taking place when there is a carbon-carbon single bond, and an sp2 hybridization takes place when there is a carbon-carbon double bond, and an sp3 sp hybridization takes place when there is a carbon-carbon triple bond. Now, why exactly they are sp3, sp2, and sp is something we'll be doing in a while. Now over here you can see some numerical values of S and P's. That is simply according to what their composition is. We can see that sp3 means S, P, P and P. That there is one S and three P's. So there are a total of 4 components and there is only one S. So that means that there is 25% of S, and there are 3 components of P out of 4, so there is 75%, and so on. That is all how these compositions are here. sp2 means S and 2 P's, so out of 3 components there is one S component, so 33.3% S, and 2 out of 3 are P, so 66.7% approximately is P. Then finally sp is just 2 components, one given to each of S and P, so it is just 50-50%. Now these are the 3 types of hybridizations that we'll be doing in detail in the next slides. Recall the fact that s orbitals are spherical and p orbitals are lobe shaped. Now in this video we'll be only covering sp3 hybridization. sp2 hybridization and sp hybridization is something we'll be covering in the next video. Now, a point to note before looking at all these electronic compositions that we have written for ground state, excited state and hybrid state, you have to notice that sp3 hybridization takes place in compounds which are tetrahedral by nature. Shapes of molecules are done in another video which you can find in the course. Now first you need to recall that carbon has a proton number of 6, meaning it has 6 electrons, 2 electrons going in the 1s orbital, 2 electrons going in the 2s orbital, and 2 electrons going in the 2p orbital. Now in the ground state, this is the electronic configuration which we used to have, right? The arrows, the opposite arrows denote 2 electrons and a single arrow denotes 1 electron. Now in ground state it's this, right? There is one vacant 2p orbital. Now what happens is in excited state energy is gained and the electron in 2s jumps. In informal terms it jumps to the 2p orbital, and so now instead of having 2 electrons in the 2s orbital there is only 1 electron, and instead of having 2 electrons in the 2p orbital there are 3 electrons. Now what happens in the hybrid state? In the hybrid state the 1s orbital will have 2 electrons as they were. Now what occurs is that the 2s and 2p, due to chemistry, these two orbitals join together at an intermediary sub-level, and this is called the hybrid. This is the sp p p, and you can clearly see why, right? There is one 2s orbital which comes over here, and there are 3 2p orbitals which are over here. which can be clearly seen, right? Now this, a point to note in this is that the sp3 is at an energy level between 2s and 2p, not more than that and not less than that. Now what exactly is the electronic configuration? We will study that right now. We can see that the 2s orbital had one electron, therefore the s orbital in the sp3 will have one electron, and all three p orbitals in the 2p subshell had one electron, and therefore this will be how it looks. Okay, now basically this is the sp3 hybrid, that is what we term it. This is the hybrid orbital, and these are the valence electrons of carbon that are used. Now, how exactly this takes place in compounds? We will be using the example of methane. Now, methane is a tetrahedral structure, right? We already know that because one carbon has 4 hydrogen bonds bonded to it. Now, the red circles that you can see in this entire compound, the red circles are s orbitals of the hydrogen, in which the hydrogen has its valence electron, and the green ones, these are the sp3 hybrid orbitals. Okay, that is something you need to note. So the sp3 hybrid orbitals bond with the s orbitals of the hydrogen, and that forms this 3D structure of methane. Now a point to note is that the sp3 hybrid orbitals form single covalent bonds, which are also called sigma bonds. Okay, that is something you need to note. There are no pi bonds in this. Pi bonds are something we'll be discussing in a later video. So an sp3 hybrid orbital will only form sigma bonds or single bonds. Now that is all for this video. Thank you.